All right, everybody. Welcome to Lesson 8.3. I'm going to warn you, put your seatbelt on. This is a lot of information. You may want to watch this video more than once. You might just want to watch it once tonight and then come back and watch it again later in the chapter when it makes a little bit more sense to you so you can make sure that you really have this. Lesson 8.3 is a big deal. Hence, you can see that the lesson itself is slope and y-intercept. And I say it with my best shot at a James Earl Jones voice because this is really the main deal. You could argue it's definitely the main deal of this chapter, but this is one of the main deals along with solving equations that will really set you up well for Algebra 1 next year. Okay? So, people keep asking me, where's Ben? He's back! So Ben's going to be helping me in this video, and also Alice Rogerson is here to help me too. All right, so stay tuned. And let's talk about slope and y-intercept. So let's first of all talk about what slope is. Okay, slope is pretty easy to describe. If you're thinking of a hill, the slope of a hill is how steep it is. All right, that's it. That doesn't seem so bad, right? Like, what's the big deal about that? Well, all right, so steepness of a line, that's a good intuitive concept for us to understand. But we need to make this mathematical, so we need a very precise way to measure the steepness of a line. So we're going to define slope to be the rise over the run. All right, now I've got all these analogies to kind of go through with you, so just bear with me. When you go upstairs, you may not know this, but if you were a carpenter, the boards that make up stairs, if you kind of look at a cross-section from the side, these vertical boards here, here, and here that hold up the front of the step, they actually have a name. They're called risers. Okay, and they serve a couple purposes. One, they make the stairs look a lot nicer when you're walking up, so you don't, you know, so sometimes you come up from basement stairs and there's just kind of like openings between the steps and you can kind of see down below the steps. All right, so, you know, really nice steps going up to your upstairs in your house. You probably don't want to look through the steps. So most steps have risers. They also serve a functional purpose. When somebody is walking down steps, especially if they're going very quick, they tend to step just on the front part of the step like this. And so what the risers also do is they actually give the front part of the step additional support. So those are called the risers. And that is not coincidentally what we're referring to when we talk about the rise on the top of a slope. The other function, the runners are the boards that you actually step on steps. So those are the flat horizontal boards that you actually step on, whether you're going up or down. They're what your foot actually lands on. You only hit a riser if you accidentally stub your toe and kick the riser. So the runners are the boards that you step on, and the risers are the boards that are vertical. Okay. All right. So this idea of rise over run. Well, let's say you have steps that aren't very steep, and you have little risers and big runners. Little riser, big runners. Little riser, big runner. All right, so this would be, and you look at this, is that a super steep staircase?
No.
No, it's not a very steep staircase at all. And the reason is because the rise might be something like 3 inches, and the run is more like 7 or 8 inches. Okay. Now, on the other hand, you also sometimes have steps that go up into like a loft, where you might have a riser like this and a step like that, and a riser like this and a step like that, and a riser like this and a step like that. Now the risers are bigger than the runners, so that, look, isn't that a pretty steep slope? Yeah, so that's the idea. That's how we're going to measure rise and run. That's how we're mathematically going to give a number to slope. All right, there's another way that we describe rise and run. In a science class, what Greek letter do we use a lot of times to represent change? We saw this when we were doing percent of change problems a chapter or two ago.
The triangle.
The triangle, right. It's the Greek letter delta. Good job, Alice. Okay, so the Greek letter delta means change. So another way to assess what the rise is how much we're changing vertically. It's the change in the y values, correct? Mm-hmm. And the runner is basically akin to the change in the x. Okay, so what is slope? It's the steepness of the line. How do we measure it? It's the rise over the run. What does that mean? It means we measure how much is going up and down first. We put that on top, and then we put how much is going left and right, the run, on the bottom, which is a little counterintuitive, right? We would like x and y, you think alphabetical order, when you look at an ordered pair, x comes before y. So you'd expect the x's to be on the top of the fraction and the y's to be on the bottom of the fraction. Well, it's not like that. So you got to be really careful. It's the number one mistake people make when they're computing slope, is they put the x's on top and the y's on the bottom. All right, let's look at the actual formula to find the slope. So let's say I ask you to actually find the slope between 2 points. Well, you're going to need to nail this down even more. So let's take that idea of delta y over delta x, and let's actually turn that into a formula. Okay? So what we're going to do, the formula for the delta y is how much difference there is between two y's. So the way we're going to compute that is we're just going to subtract one y from the other. So we're going to call it y2 minus y1. Now those are not exponents, those are subscripts. That just means one y subtracted from the other one. And you don't have to, but I think a good way to keep track of this is call your first point, point 1, and your second point, point 2. Sorry, my recording just paused. Alright, so we've got y2 minus y1. That'll find the difference in the y's, and we'll put it over x2 minus x1. Alright, so what was the number one mistake, guys, that I said people make? They forget to put what where?
The exponents.
Nope, there's no exponents.
No, never mind.
They put the x's on top and the y's on the bottom, right? So that's the number one mistake. The second mistake people make is they don't go in the same order. So it's a good idea to actually put the little number 1 sign and the number 2 sign. So what we are going to do is we're going to actually draw an arrow. We're going to say we're going to subtract the first point from the second point. So let's go ahead and take this formula, and let's go ahead, we'll do this one in red, okay? And let's go ahead and subtract. So this is going to be -7 is the y2, because it's the y value of the second point. Everybody with me? Okay. Minus the y value of the first point, which is -1. Now be careful. What do you always do when you put -1 into a formula? You always put parentheses around it. Anyway, anytime you have a negative number. We're going to divide that. Let's do the same thing with the x's. So it'll be 0. That's the x of the second point. That's x2. Minus the x of the first point, which is -8. All right. So on the top, 7 minus -1. Well, that's really just 7 plus 1, right? -7 plus 1 is -6. Divided by -8. And what happens when I have a negative over negative?
It changes into a positive.
Right. They cancel out. They become a positive. And 6 over 8 can reduce down to?
3/4.
3 over 4. So the slope between those 2 points is 3/4. All right, now I got one more last weird, confusing thing. The mathematician that came up with this whole idea of slope by measuring the vertical change and dividing by the measure of the horizontal change and all that nonsense, well, he happened to be French. Why do we care about that? Well, because the word for mathematical rate of change in French starts with the letter M. I kid you not. So this letter to this day that we use when we're talking about slope, which isn't in the word slope in English anywhere, is the letter M. So the M of the equation, the slope of the equation, is 3/4. Now, right now that probably seems really weird to you, but you will get very used to using slope, so this will become very second nature, and it won't even seem weird to you in a couple weeks. But for right now, it seems weird. All right, so let's do the second one. All right, why don't you go ahead and pause the video? We haven't done that in a while. So pause the video and use the formula right here for the slope, and use, and I'll give you a hint. You probably want to go in this order. So we'll call this point number 2, and we'll call this point number 1, and go ahead and find the slope, and then press, then unpause the video, and we'll see if we get the same thing that you get. Okay? So pause the video now and find the slope. All right, everybody, welcome back. So again, the slope, the letter is M, and you can write out the whole formula, or you can just write out delta y over delta x. I like to do that. So that just reminds you to put the y's on top. Especially these first couple when you're getting used to doing this. This would be a helpful thing to not accidentally make that mistake and put the x's on top. All right, so we're going to get 9 minus 3, agreed, over -10 minus, again with the negatives, minus -4. So that's going to become the 9 minus 3 on the top is 6. That's pretty easy. And -10 minus, let's change this to plus. So -10 becomes +4, and that becomes -6. And what does 6 over -6 equal?
-1.
-1. So the slope is -1. Okay, so if you got -1, you're correct, and there was the slope. The first one, 3/4. All right, now let's talk about a little bit more about slope. All right, so far we've talked about slope is the steepness of the line. It's the rise over the run. It's the delta y over the delta x, or we could actually use this formula here. It's y2 minus y1 over x2 minus x1. And remember, those are not exponents. They're called subscripts, actually. And what they do is they tell the difference between 2 different y's and 2 different x's. All right, now the fun part. Let's talk about some special cases. Okay. Oops. Let's talk about some special cases. All right, first of all, this whole idea of steepness of a slope, being the winter and all, and I know it's almost spring, but Fayette County had a snow day today. If you put together winter and steepness, you might think about what?
Skiing.
Skiing, right. So suppose you go skiing for the first time, and you go with somebody who's not very nice, and they take you to a hill that looks like this. And by the way, there is no ski center anywhere in the United States that has a hill that looks anything like this. I know it feels like that, but a really steep black diamond slope is usually a slope of about 30%. and that would be a black diamond. If you actually skied down a hill that was 45 degrees and you fell, you would not stop till you hit the actual very bottom of the hill. Now, there's little sections maybe where you kind of jump off a little lip that might be that steep, but hills are not as steep as they look. In any case, suppose this friend of yours takes you skiing, and they don't really tell you anything. They just point you downhill, and here you are with your little skis, and you are skiing, and you probably have a look of absolute terror on your face, and your poles are sticking out, and your scarf is sticking out, and your hat just fell off. Okay? And you see that you are skiing really, really fast out of control, and you're going to hit this little lip, and then you are going to fall off a cliff.
Or just fly.
Well, you might be tempted to utter a few things. And some of those things that you might utter are probably things that I can't put in my video. But some of them I can. One of the things you might scream as you come across this edge and then plummet to your certain death, okay, is you might scream, "Oh, no." And the reason you would choose to scream, "Oh no," is not because you are worried about your impending doom, but because you want to remember your last object lesson in mathematics before this unfortunate skiing incident. And what you are remembering is that Mr. Gunn taught you that when you have a horizontal line, does it have any steepness at all?
No.
No. So we call that a slope of 0. So we say m equals 0. However, when you have a vertical line, does that have steepness? Oh, yeah! It has major steepness. It has so much steepness that we don't even really want to think about skiing down a vertical line, right? In fact, it's so steep we don't even give it a number. We give it either an undefined slope, which doesn't exactly rhyme with my oh no, or we call it no slope. So what are you screaming "oh no" for? Because you are remembering that just before your death, you are going to ski off of 2 horizontal and vertical portions of the ski slope, one of which has slope 0, oh, and one of which has slope no, or no slope. So you're yelling "oh no" to remember those little lessons. That's my corny mnemonic device. Something else that's really cool about slopes that will help you remember things, if you're going from left to right and you're going uphill, whether you're going gradually uphill or very steeply uphill, those are positive slopes. If you're going downhill, either really steep or not so steep, those are negative slopes. So just by looking at the sign of a slope, going from left to right, positive slopes go uphill and negative slopes go downhill. All right, all that from slope. It's actually pretty handy, isn't it? Okay, so again, slope of a horizontal line is 0, and slope of a vertical line is no slope. By the way, remember that the equation for a horizontal line would be something like, sorry, I almost mixed it up. It would be y equals some number, some constant c. And the equation for a vertical line would be x equals some constant c. All right, let's move on. Okay, I know we're at 12 minutes, but I've got one more thing I've got to throw in here, and that is y-intercepts. Okay, the y-intercept is really simple. If I have a graph like this of a line, the y-intercept is exactly what you think it is. It is where the line intercepts the y-axis. So if this intercepts at the point 0, 2, we say the y-intercept is equal to 2. Now, unfortunately, this also has a weird name. In a weird letter that represents it, and it doesn't have anything to do with nationalities of mathematicians. We just use the letter B because sometimes in some books they use A for slope instead of M, and so the second part of the equation is B, so that's why it's B. So y-intercept is almost always B, and don't forget slope is almost always M. Okay, so that's just the letters we use for slope and y-intercept, and neither of them are very intuitive because again, there's no M in the word slope, and there is no B in the word y-intercept. Also counterintuitive is when we did slope. We put the y's on top and the x's on the bottom, which is anti-alphabetical order. So there's lots of little tricky things to remember about this. Okay, let's take the idea of y-intercepts and the idea of slopes and put them together. If we put these together, we're going to get an equation that's going to look like this. Y is my variable, is equal to m, the slope, times x, plus the b, the y-intercept. So if I see an equation in this form, like let's say I have y equals 2x minus 4. Okay? So just from what I just taught you, without even talking about what it stands for, we know that the slope is 2, right? Because it's the number that's times the x. And we know that the b, be careful, include the sign, so the b would be the negative 4. So in this one we have slope equals 2 and y-intercept equals negative 4. All right, now watch this. This is prepare to be amazed. Okay, this is cool. So let's take y equals 2x minus 4, and let's look at it on graph paper. So let's take y equals 2x minus 4. Again, the slope is 2, and the y-intercept is negative 4. All right, let's talk about how to use slope now. All right, so first of all, let's count up 4 units. That's where this is going to cross the y-axis, right? We'll get this point right here. Everybody agree? Mm-hmm. Okay, and let's talk about the slope of 2. The slope of 2 is equal to the change in the y over the change in the x. Now, hold on a second. That's not actually a fraction, is it? All right, so here we go. 2 is not a fraction, so let's change it into a fraction. Let's make it 2 over 1. Agreed? Mm-hmm. All right, so if 2 is the vertical change, watch what I'm going to do. I'm going to go from this point here, I'm going to go up 2 units to right about there. Okay, then I'm going to go over to the right 1 unit, and I get this point right there, the blue point. Now do that from that point, go up 2 and over 1 again, I get this point. Go up 2 over 1, and I get this point. Notice I didn't have to do any big chart of values this time. I didn't have to make a chart and make up x's. Look, I just graphed the line. By the way, could I also have done negative 2 over negative 1? Doesn't negative over negative equal positive 2?
Yeah.
Yeah. So I could also go, and this means the vertical change means go down 2 and go left 1. Go down 2, go left 1. Go down 2, go left 1. What do you notice about all these points?
They're like
in a line.
Yeah, they line up perfectly, don't they? In fact, if I go ahead and take my little line tool here, let's make it really thin, okay? And I go like this, I want you to notice that all of those points line up perfectly, don't they? Okay? Yeah, so that is how you graph a line, using slope and y-intercept. Okay, I won't bore you anymore. I know it's been a long lesson. So we'll wrap it up there. So things to remember. Remember that, that y equals mx plus b is called the slope-intercept form of line. Okay? Remember that the m is the slope, which is the change in the y over the change in the x, the rise over the run. Or more importantly, if you actually want to do the formula is y2 minus y1 over x2 minus x1. And the weird letter that we use for that is the letter m. Okay? The b is the y-intercept, and it just tells me where my graph crosses the y-axis. So it gives me a point on the graph is all it gives me. Yep. And from that point, I can use slope and I can figure out the thing. Also remember that the slope of a horizontal line is 0, and the slope of a vertical line is no slope. Okay? You need a slope to ski on. When there's no slope, you are plunging to your death. That is not called skiing. That is called dying. Okay. All right. I apologize for the long video, but like I said, this is a big, big lesson. And this is, as long as this video is, you're probably going to want to go back and rewatch this prior to the Chapter 8 test. So I'm going to shut up now. We will practice in class tomorrow. I thank you for your patience. I thank you for watching this. If you did not get a lot of that video, if this is not making sense to you, don't come in tomorrow and say that didn't make any sense. Get out your book and maybe watch through this video one more time and try to get this stuff straight. We will practice this in class tomorrow, but I expect you to basically have the basics. All right. So Alice and Ben, thanks for helping, and I'll see everybody else in class tomorrow.
Bye.
Goodbye.
Pizza.